So yeah. So let's understand the basic difference between the cores and the threads, right? So you must have understood that the machine that you are trying to use right now, right? Someone's machine must be 6-core machine, someone 16 core, 32 core, or anything. So if your machine is a 16 core machine, it means it can only run 16 threads at a time, no more than 16 threads at a time, right? Uh, Only if you are using Intel's hybrid chip, it's a different concept. You can use 32 threads because that is designed in such a way. So let us play a small thing, and what I can do is can someone, I mean, everyone open their mobile and just scan this QR code. And can you help me that if I implemented a code which is just giving me like hello world and nothing else, right? You can scan this QR code and you will get this question in your phone itself. And oh, sorry, I think that question is wrong. I'm sorry. Yeah, this is the one. I don't know why it is taking the wrong question.
I can see the right question now on my screen.
Yeah, sorry, this is the question, right? Yeah. Uh, So you are able to see this question, right? If you scan this QR code, it would be considering that there is a request that I am sending. So where I'm asking that can jump to their six times their height, right? And this is a 16 core machine where I am sending 100 requests concurrently. So what do you think would be the answer? Would it be able to handle it or would it not be able to? I think we have enough responses in this one, and the most of that comes is like yes, with proper concurrency management, we can do it. And yeah, I think that's the one that you can obviously do it. So, so to understand that what is the difference between a parallel and a concurrent, so we can use a very simple analogy, right? Uh, Imagine this that you are walking into a restaurant and there are 8 waiters, right? So 8 waiters are representing the 8-core CPU, and each waiter can handle 8 customers at once, just like the CPU can handle. So now each waiter is given just one customer to serve. Everything works smoothly, no problem, right? But let's say that tomorrow there are 60 tables and the waiter has to handle all of them at once. So how do the waiters manage that, right? So if there are 8 customers there, they have to switch between one. So if they're going to table one, they want a drink, table two wants some food, table three wants some dessert, and they will be looping between them. So this is just a very, very basic analogy of what is the difference between parallel and concurrent. So parallelly, everything is working at the same time, but concurrently, it's just switching the task between them. So to understand more, you can take this diagram into illustration and you can see that what is, so you can consider this is one core and these are the 2 core machines. And this is where your requests are going parallelly and this is where your requests are going concurrently, right? So once you know the basic on this one, what we will do, it's just we will try to hit a request where what we are trying to do is sending a hello request. It will just return us hello and it will wait for 3 seconds. And what I have done is at one time, the server can only take 10 requests, no more than 10 requests, right? Uh, And if I try to run the application, and if I hit 10 requests, see it the total execution time it actually took is just like 3 seconds. In 3 seconds, everything is done, right? Now, what would happen in a case if I try to hit 20 requests at once, right? You can view on this one. So first the 10 requests are completed in the first 3 seconds, and now it again takes 3 seconds to complete three more requests, right? So what would be the solution for this one, you would be asking, right? So the very, very simple solution would be to increase the thread size, right? So let's say that I increase the thread size by 30. So it means that now I can hit 30 requests concurrently, right? Let's just run it again. Test it over here. And if I try to run 30 requests together, it is all of them are completed in 3 seconds, right? Now, just for the testing scenario, what I will be doing is I will be hitting 2000 requests at once, just to ensure that when we are working in a real scenario, there might be we might be receiving a lot of requests if your application is very, very used by user, right? So let's try to hit 2000 requests. And 2000, clear this up, run it. All of them are done, right? So if you see, the error rate is 0% right now, and all the 2000 requests have been completed successfully. These are all the requests. But what I will do is now I will use the same code in an AWS EC2 instance, which I've already hosted, and let's use it over there. Let's take this one. Let's change the IP. Let's clear the result. Now, the application that is deployed in AWS EC2 instance is exactly the same which we are currently using. I mean, we are using 2000 number of threads over there, right? So let me just try with one of them and let's see that the EC2 instance is working or not, first of all. Oh, it's not. Actually, I need to start the jar file. Right, I am inside this one. And if I try to build the image, so currently now the application is working in AWS, and let's try to hit the request now. Yeah, see, it completed. Yeah, the instance was not started. So you can see that we are seeing a response of hello, and it is sending the IP address of the same. Now, what I will do is I will try to hit 500 requests that we had tried to done at the same time in our local machine, and let's see if that works. Yeah, see, it did work, right? So what if now in my local machine, I try to use 2000 requests at a time. If I try to hit 2000 requests and the ramp up period is 0.1, 0.1 means in 0.1 seconds, it will try to hit 2000 requests just in 0.1 seconds, right? So let's go over here and write 2000, right? What if I try to run this right now? if you see, we are facing a lot of errors right now, that we are facing 13% of error, and all of them requests are not queued within 3 seconds, and already 23 requests has been passed. And after a point of time, it will stop responding after 16, 17. I mean, 1617 requests are still yet pending to be processed, right? So okay, it is trying to work, but error rate is also over there, and we are using. I mean, the point is that the server is taking a really long amount of time, that is taking 44 seconds or something, right? So what needs to be done in this scenario? So first of all, what happened, the server has started to crash, and before actually investigating into the failure, that why this has stopped working, I think it's essential to understand a very, very basic of how the concurrency and the system resources are handled in the system, right? So let's move to our presentation. So this is just, I won't go into too much details, but we can understand there are two types of memory, right? So one is the heap memory and other where all the various things are shared. So let's consider that you are working in a restaurant, right? So what you will be cooking, you will be cooking something like parathas, rice, dals, and everything, right? So those food is used by everyone, right? So if customer one comes, they might also eat rice, and customer two comes, they might also eat rice. So you can share the memory between them, and those are stored in the heap memory, right? Now, imagine something that someone like me who doesn't eat onion or garlic. So I go to the restaurant and I say to the waiter, "Hey, waiter, you know what? You can cook my food, but don't put onion and garlic in my food, right?" So that's a request that is specific to me. Once I move out of the restaurant, they don't care that what request was served to me. So this specific information, whatever there was, right? So that is stored in the thread stack, and that's the reason it is not stored in heap memory. So this was just a basic thing that I just wanted to share about like how this works. And roll back the changes to chow. So now this is just one another thing that I have done is like it will send a lot of requests, and I will be seeing that how much memory is actually JVM using. Like what is the memory that is being used by garbage collector, what is the memory that is being used by heap memory, and things like that, right? So first of all, what we will do is we will keep our threads again to 500, and let me stop the application. Let me open JMeter again. Right. And 0 and 500 request stats once. The application is not started. So if you look over here, the maximum JVM overhead size that has gone is 123 MB, and the maximum heap memory that has gone is 78 MB when we are trying to hit 500 requests, right? And as soon as you increase the size of the threads and you try to hit all the requests again, and let's use 2000 threads. So you see there is a slight increase in the heap memory. And if I put 4000 threads now and try to hit the request, it has gone to 423 MB, right? So what does this mean? And all of the things that we discuss right now, right? The memory matrices, the heap, the JVM and everything, all of this is stored in the RAM and it is not stored in the SSD of what you are trying to cover it up. So when we were using the instance of AWS, it was a T2.micro instance, which has approximately only 1 GB of RAM. And what we saw now is that when the memory usage increases, JVM tries to find more memory, that it needs more RAM and more RAM. And because this PC has lot of amount of RAM, it was able to take 2000 requests at one time. But because the server in AWS didn't had, so it was not able to do this, right? So when you would look into this, so you would think, okay, so if my requests are not working concurrently, what I need to do is I need to increase the number of RAM, right? Well, let's see. If you think that RAM size really matters, what we will do is we will have one more task where, right. So what has happened is like, first of all, it was not working. So what you did, you went to AWS, you increased the size of the RAM. And when your stakeholders ask, say, hey, how's the project going? And you would be saying, yeah, it's going exceptionally well. And the next day, a new task comes. The next day, a new piece of code that needs to be integrated, right? So what we are doing in this task is we are calculating the square root of number from 0 to 1000 crores, which is actually 10 billion, right? Now this is an operation which is a very CPU intensive operation. This won't take like a, we are not hitting too much request via this. We are just taking too much amount of CPU into this one. And what we will do is we will just try to hit 5 requests using this one. And this is in the long. Let me just verify if this API is working or not. Right. So how much time did it took? It took like 5 seconds, right, to do this entire thing. Now let's try to use the JMeter for the same thing, and we will just hit 5 requests at the long one, and let's try to see how much time does it take. See, there were we just sent 5 requests, and at how much time did it took? It took 6 seconds, right? Now, what if I go over here and try to send 100 requests? Even the thread size is currently more than 100. We will just try to send 100 requests. And let me open my terminal. And you can see on this one. Let me just close this one. Top. So top, what it does is gives that how much amount of CPU is being used currently in your system, right? So if I send 100 requests, you see 960% of the CPU is being used currently. So how it works in this PC is like if one core machine is being entirely used, it is using 100%. So 10 cores in your PC are entirely being used right now. I mean, 10 cores are totally being used right now. And even though we have the thread size set more than 100, still 100 requests are still pending. So what is happening is like everyone is fighting for resources right now, is right? So think of it like 10 people are going to the restaurant together and every one of them is saying कि ये सब 10-10 कर दो, गोभी पराठा, मेथी पराठा, पनीर पराठा, लच्छा पराठा, तीस पराठा, पालक पराठा, ऑनियन पराठा, चिकन पराठा, कीमा पराठा, सूजी पराठा, right? So the person gets confused that how much can I take in the same thing. I mean, they are able to cook everything. They can take gobi, methi and paneer, but they can't do everything at the same time. So that's what the thing is happening. The CPU is getting overloaded, and because of that, you see 1 minute has passed, and then 100 requests are being completed, where actually it was only going to take 5 seconds. Now, what we see from this one is two things, right? Increasing the max thread size doesn't guarantee that you will get a faster response time. And second thing is increasing the RAM doesn't always solve the problem, right? So now what your solution would be, what you would try to say, ki, you know what I will do? if there are two instances, I will create two instances in EC2 instance. One of them would be on the CPU instance would be on one EC2 instance, another would be on second EC2 instance, right? So for now, I have not taken the CPU intensive one, but we will try to solve the one that we were facing earlier, right? We were not able to send 2000 requests. So what I have done as of now is I have created a VPC where we are using, you can ignore the private subnets. We are just considered with the public subnets as of now. So okay, you can consider it like there is a big cloud over there, and there are two instances that are created, instance one and instance two, and there is a load balancer that is being used. And first, the request will go into this one. If I send second request, it will go into this one, right? So we'll try to see that if we try to horizontally scale our system, does this actually help our system to grow or not, right? So let me copy the URL of the load balancer just to let you know if this is working on. I had one. Yes, there is one, right? So if I go to this load balancer and I copy the DNS name, so just to let you know that this thing is working, I will hit the same hello request. What it does, it waits for 3 seconds and it gives the response, right? So first of all, it went to my first instance. Now, if I send the request again, it will wait for 3 seconds and it will go to the another instance, right? So what now I have done is I have also increased the thread size. I have also increased the RAM size as well, right? So I have another one. So now you can go to the same QR code as of now, and you can try to think that what if I send more than 1,000 requests to the same EC2 instance, right? So it was able to take first, it was able to take 500 requests, right? And now we have also increased the RAM size as well. So if I increase the number of threads to more than 1,000, would it work or would it not work, according to you? Let me just try to hit one request to see if it's working or not. Hello, this is the request, and the port shouldn't be defined over here as of now because we are using the load balancer, right? Yeah, the request has passed. Let me see if you guys, okay, won't work. So you think that this, if the only thing more buggy than my ADHD is Java. Okay, right. Let's try to hit first a request which are limited to 1,000 requests, right? So if I go over here and I try to hit just 500 requests for the first time, and currently the max thread size is also set to 2,000, right? And let's try to see if that is working or not. 1, 2, 3, 4. Okay, it took 4, and the error ratio is 0.4. Okay, that is still negotiable at this. Oh, I think because of these two it has done. And now if we go this one and try to hit 1,000 requests, okay, that has also worked. What if I go more than 1,000, right? If I go for 2,000 requests at the same time. It did work. Okay. What we will do is we will keep testing Java that up what point does it think that it feels right. It is still working within 0.0%, right? Right. So if I had used the same instance of 1 GB, it would have definitely failed over there. But right now, what we have done is we have also increased the size of the RAM as well, and this one also, right? And because of this, it is able to find enough resources. But if it was something computative intensive, right? The same that we did on the one, like calculating the prime square root from 1 to 1000 crores, right? Then it would definitely have failed. So now if the stakeholders come and ask us that, how is the project going? And you will be again saying, you know what, the project is going exceptionally well for the second time. And next day, another requirements comes into picture, is a totally different requirement for you, which is the fourth one, which is the thread stack, right? And what I have done in this one is we will just try to hand one more we will just try to send one request, and I am trying to make a very recursive call. It's not doing anything. It will just do a recursive call to this one, and it will pick a random number from 2000 to 3000. And what it will do is it will multiply the number by 2, and it will go till the number decreases. Let's say the number was 2500. So it will calculate the random number 2500 times, and then it will move out of the loop. So this is what is happening in the recursion as of now, right? So if I try to open this, what is the URL? This is our URL. Recursion completed, right? What I will do is I will do a very small change as of now over here. So instead of 2000, I will use 20,000 over here, right? And let me rerun the server. And I will try to do the recursion. And what happened? We are facing some error over here, right? We are just trying to hit only one request, no more than one, right? We have got enough resources, we have got all the RAM we need, so this should work, right? So why do you think it won't work at this time? And you would be thinking like, I hate Java too, and honestly, even my PC doesn't know what is working as of now. So every time you try to open your laptop, your the VS Code, the stock price of Microsoft loses 5 points. It's like your laptop is causing a market crash, and you don't even know what is happening as of now. So now the manager comes for you and asks you that how is the project going, and you would be like, you know what, it's again going exceptionally well. But only this time you know about the exceptions that we are talking about. It's about the exceptions, and it's not going exceptionally well, right? So again, how do we solve this kind of situation, right? Where you just have one request, but it is taking so much of things. Now, the reason it has failed is, if I go to the fifth one, solution to this one, it's not sure. This one, right? So what happens is the image that I showed you, right, some time ago, right, about this keynote. So first is the heap memory, and that's the second is the thread stack memory, right? So every thread in the entire application is given some amount of memory. So let's say that you are running the application, and what you go and order is like, you give me dal fry and jeera rice. This is the only thing that the waiter needs to remember, and it's so easy for him to remember the two things. But you are giving him so much things. Just we talk about all the parathas, right? Muli paratha, gajar paratha, and everything, that he is not able to remember everything. So the same thing is happening in recursion. Whatever is happening in the recursion is only required during the same time, right? They don't need the memory. We don't need to put all those into the kitchen's memory. We just need into the same memory. So a thread is given a default memory of 512 KB. So when we are trying to hit more than 20,000 recursion points at the same time, the memory of 512 MB is getting exceeded, right? So that's why it's not able to go to that position. So what we will do in Java, what you can do, you can always change the uh, size of the thread, right? That each thread, I mean, each request that you are trying to send should able to consume 10 MB of resources. So this is just what I'm telling, that you don't take 512 KB, but instead you take 10 MB of the memory, right? So I don't know how do I run it from IntelliJ, but we will just run this from the command itself. I just need to do Gradle build once, because Gradle build. This is not okay. And now if we go over here and try to hit the same request, it shows that the recursion is completed, right? Now, just because of this one thing, right, that the recursion is taking a long amount of time, you won't be actually setting your thread size to something like 10 MB, because each and every thread needs 500 KB or something like that, right? So just because of one thing, we can't do it. So all of this just to explain a new concept that has been introduced in Java. So moving to that one, in case if anyone has any questions till now, we can go ahead before moving to the last topic that I wanted to discuss on this one. Okay, so now I will just switch to the last one. This is the sixth one. Check out, right? And what as of now I have done is my thread size is 10. I mean, in a moment it would be able to take only 10 requests at a time, right? The thing with that we saw earlier, if I go to HTTP and I go to this one and put 8080, let me run the application again. Then so 1, 2, and 3, it all got completed in 10 seconds, right? Now, what if I send 30 requests, right? The same thing that we saw. It is definitely going to take 9 seconds, right? First, it will consume 10 requests, then it will take 10 requests, and then it will take 10 requests. Yeah. So as a solution, what you would be thinking that if I need to do this, what I will be doing is I will be horizontally scaling my system, right? That if I am getting 30 requests, I will have three EC2 instances so that the traffic is divided into three of them. And you were right, we can obviously do that. Now just imagine that you have 20 instances. The cost of maintaining these instances would go sky record, right? So how much memory would it take and how much cost you have to pay, right? For that one. And now, a new thing that was introduced by Java in JDK 19 was the concept of virtual threads that was there. So what they say that so Java has been working on various projects like Project Loom, Project Valhalla, and everything. So under Project Loom, they have introduced a new concept which is called virtual thread, and it was introduced in like Java 19, and it was stabilized in Java 21. And Java says that a virtual thread is a lightweight thread, and it is actually faster than the platform threads. So let's see if it's really faster than that or not. So to do that, you don't have to do anything. You just have to include one more line over here. That is virtual.enable equals to true. So whatever the threads that we are trying to run over here, it will try to run it in virtual thread. So it is just as simple as like saying to Siri that just hey Siri, use virtual threads, things like that. So if we go over here and if we try to do the same thing, right? First, let's just hit 10 request and see how much time does it takes, right? Did I restarted my server? I hope not. One, two, three. Boom, it's done, right? Uh, Let's try to hit 20 requests now, and let's see what happens. 1, 2, 3, boom. So virtual thread is saying like, give me something good, right? I'm obviously able to do it. So let's try to send 100 requests at a time. Boom, it completed in 1, 2, and 3 seconds. Instead, if you had used the same thing on the platform thread, it would have actually taken 10 into 10, that would be 100 seconds, right? So 1 minute and 40 seconds. So you know what? I don't like this. I just hate Java. I just want to see if where at what point that is breaking, right? So I will try to hit 1000 requests at a time. It again got completed within 3 seconds. I can't bear why Java is working so nicely, right? So I will try to hit 2000 requests at a time now. Again, it goes 1, 2, 3. It again completes within 3 seconds, right? So you know what I will do is I will go to 10,000 requests at a time. So what we're trying to do is we are hitting 10,000 requests. If you would have used a platform thread over here, it would have actually taken 10 GB of RAM over this time. It means you need the resources of 10 GB of RAM to hit 10,000 requests at one time, right? So let's see if this is working or not. It's still working. But the thing is, if you come over here, you would be seeing that only 6,096 request has been completed. Because the thing is, this is not the thing that Java has failed. It's the issue with the OS itself. So every OS, I mean the operating system that you are trying to use, that has a hard limit that how many threads you can allocate, and you can't change that limit. So I'm still trying to figure out that is this issue is caused by the JVM or the JMeter or the combination of both, right? But still, the point is it would be able to handle 10,000 requests. So what we will do is I have the same, not this one. Testing, yeah, this one, right? So I think that's the issue with the JMeter, that is not able to allocate that much amount of threads. So what I have done over here is first we will try to just use a normal thread and not the virtual threads. And we will try to hit 10 requests and see how much time it's taking. So what I've done, I have done the same thing, but I'm not doing it in Spring Boot, but I'm just using a normal Java code just to see that how much thing it would take. So uh, I'm again doing the same thing, like waiting for 3 seconds, and I am going for the 10 request as of now and see that how much time does it takes, right? So there are 3 requests. If we are using just the normal thread, it is taking around 12 seconds, right? And if I try to do the same using the virtual threads, now, optimization is a very, very, very difficult thing. So in case you are working somewhere, you just have to change this one line, right? If you are using new fixed thread pool, you just have to use new virtual thread task executor. You don't have to change anything else in the code. So if the stakeholders ask you that how much time it would take for you, you can definitely say, you know what, it's a very hard change. It is going to actually take uh, a month for me. So I need to go it in a beach and try to do it on a vacation because this is a very hard change that you need to do. You need to change one line of code just to have virtual threads enabled, right? So let's try to do and try to hit 100 requests and see how much time does it take. It just completed in 3000 seconds, right? And what we were trying to do is we were using 10,000 threads, right? So it is still using 3000, I mean 3000 milliseconds, which is around 3 seconds, right? What if I go for 12,000 threads, just a little bit more? It is still taking 3 seconds, right? So it's like what is happening. I'm working on an auction. It seems like I'm keeping on increasing, keeping on increasing. What I will do is I will just try to hit 100,000 requests, right? This one last try. So in case my audio cuts off after a few seconds, you can assume that my system has already crashed, right? Because if I try to do this using the native threads, it would be actually taking 100 GB of RAM. And currently, this system has around 6 to 8 GB of RAM, which is allocated to the JVM. So let's try to do 100,000 virtual requests at a time. It still got completed within 3 seconds. So that's the power of the virtual threads that has been initiated new by the Java. And yeah, I think that's all I had from my side to share on this one. Uh, in case if anyone has any questions, I can take it. Is the thread that are used by OS, right? So this is OS thread that we are using. And the OS dedicates some platform threads. And now each platform thread would be having a virtual threads. So your PC would be shifting from one thread to other thread. And what happens when you are using a CPU intensive is all the threads are already busy. So once thread tries to move from this one, it tries to look which thread is free. It sees that none of the threads are free. So it comes back to the actual thread it's working again. So that's why it shouldn't be used when you have a CPU intensive work, but it should only be used when you have some blocking operations. I think the concept is the same in everyone. I think Ruby uses fibers, Kotlin uses Go routines, coroutines, Python uses Greenlit, Go uses routines, and Java uses virtual threads. So, and as of now, I think the best performance that is being happening is from Go, and it is working exceptionally well when you have like multiple amount of requests. But I think virtual threads might make a change in the future into like handling concurrent requests because of the virtual threads. That's what I'm assuming. It's my assumption.